SpaceX is building everywhere. We flew 2 helicopters simultaneously to capture images of Starbase and Cape Canaveral. And what we found at Starbase and Cape Canaveral Slick 37 and Pad 39A was nuts. Elon Musk stunned everyone. SpaceX wants to build 10,000 Starships per year. Is that even possible? We do the math. And we're doing part 2 of our 2026 milestone forecast. Firefly Blue Ghost, Astrobotic's Griffin, Relativity Space Terran R, PLD Space's Miura 5. My name is Felix, welcome to What About It, let's dive right in. Starship updates. And we're back. Missed me? Yeah, I missed you too. Today we start with a banger. Not that this is the only banger, but more on that later. Remember this thing from the production site? We talked about it extensively. It's the Ship Quick Disconnect, or SQD extender. And it's the biggest piece of hardware still missing on SpaceX's Pad 2. Pad 2 is where Flight 12 will launch, and it's currently the only launch pad in the world capable of supporting a version 3 Starship. That's a problem. If we want to see Flight 12 launch, this infrastructure needs to be in place. 100% built, tested, and operational. So here's the promised banger from the beginning. It rolled on January 6th from production to the pads. That, of course, can only mean one thing. It is done and ready for installation on site. And that is exactly what happened on the day it was rolled to the pads. In typical SpaceX fashion, they did not waste any time. In a delicate operation starting at 10:05 a.m. local time, teams started the lifting process. And only half an hour later, the two pieces of this brand new and redesigned quick disconnect arm were in place, ready for mating. Jordan hiked out into the salt flats in front of Pad 2 early in the morning to bring you these images. If you want to make him smile, say thanks in the comments. I'll let him know that you're sending your regards his way. Also, and I've never done this before, give him a follow on X. Search for @JordanGuidry6. He has under 1,000 followers. Let's blast him past 1,000, shall we? Thank you, Jordan. We love you. This robotic arm attached to the main Mechazilla tower is used to fuel the Starship upper stage prior to launch. Pad 1 has one as well, but this one is significantly different and almost every part was updated compared to the first version. Starship version 3 won't just be a massive redesign of the Super Heavy booster and the ship. SpaceX also undertook a rework of the entire launch infrastructure. This includes everything from the tank farm to the whole concept of how the new pad works. All this will be tested on Flight 12. Not just the rocket. That is why hardcore Starship enthusiasts are very much looking forward to this next launch. It almost feels like Flight 1 all over again. And behind all this is the Star Factory and its connected Gigabay. And there is a common misconception about the Star Factory. It is already operational, right? Right? Not really. In a sense it is, but not the way it's intended. Until a few months ago, SpaceX used this space as a replacement for the old Onion tents. Yeah, remember those? Starbase has come a long way. Those tents were just enclosed, protected production spaces. Experimental, not much organized or streamlined, slow and wild. I call it the Wild West era of Starbase. When SpaceX finished the Star Factory and outfitted it with machinery and workstations, they largely kept the concept. A bit more streamlined, sure, but not nearly what this Star Factory is supposed to be. But what about it? Why doesn't SpaceX just go full steam ahead? Why is there no mass production yet? There are two reasons for this. Number one is that version 2 of SpaceX's Starship design simply wasn't mass producible. Mass production doesn't just mean workers work faster and there are more robots to weld things. It means the item you want to mass produce must be designed for mass production. Every item and every production step must be planned. The way and order in which it's produced is essential. It needs to be baked into the design. Starship version 1 and 2 didn't include this. And that leads us directly to reason number 2, the Gigabays. One key part of mass production is end assembly. All segments and components are pre-made and then brought together. A common thing in mass production. And that place in SpaceX's Starship mass production plan is the Gigabay. And as you can see in our latest flyover images, it is not done yet. It's now roughly 1/3 of its total height, and the project is scheduled to take until the end of this year. But you can see that it is growing rapidly. Take a look at this. These are images from May 9th, 2025. Remember the mid-bay? SpaceX was still removing it. Here are images from June 19th, 2025. SpaceX had just started putting out pea gravel, one of the first steps in building a foundation. Fast forward 7 months to our latest flyover and it looks like this. You can see the structure forming. Before we go deeper into the process, here's a word about scheduling. Oh nice, Toki is calling me to remind me to introduce him to you. Today's sponsor Toki schedules things for you in seconds, syncs multiple calendars, and will make sure you never miss anything again. It's a free AI-powered calendar that schedules things in seconds and syncs all your calendars in one place. I send it screenshots of invites or schedules or just use voice commands. It adds everything instantly. And for things you really can't miss, Toki can actually call you. Download Toki for free on iOS or Android. If you want more, the premium plan gives you more events and unlimited call alerts, and you can get 50% off the annual plan using my link or the QR code on screen. Alright, all organized, back to the gigabays and why they are so essential for SpaceX. Let's use one of our 3D models as an explainer. Elliot worked magic on this one. This is what the gigabay will likely look like when done. 2 distinct corridors can be seen, 12 bays, each totaling a manufacturing capacity of 24 dedicated work bays. 24 at the same time. That's what the directly connected Star Factory was built for, not one prototype at a time. Teams will work 24/7 to feed this monster with parts and segments so that assembly doesn't stop. Never. Once this is done, I expect SpaceX to build a second one right behind it, where the current 2 megabays are situated. 48 bays, busy day and night building our future in space. And that's not all. We went up in our helicopter again, fresh images. This is the gigabay currently in construction at Roberts Road, SpaceX's hub at Kennedy Space Center. And it's grown considerably since our last heli flight. 2 more floor levels have been added and they are already working on 2 more on top. It's the same as the one at Starbase. 24 bays. This will likely be extended to much more as well. So that's 72 bays in total in Texas and Florida if SpaceX builds a second gigabay at Starbase. You can see where I'm getting with this? We've seen nothing yet. Let's take what we already know and try to extrapolate from there. SpaceX assembled Booster 19, the first version 3 booster, in roughly 1 month. Second. But okay. It's likely going to be done even faster in the future, but it gives us a good first data point. Now let's do the math. 72 bays spitting out 1 ship or booster per month. That's 864 stages per year across both locations. That's 2.3 per day and 432 full stacks per year. Still more than 1 per day. More than 1 complete Starship full stack per day from both Starbase Texas and Roberts Road combined. And as said, we are not even factoring in a faster build time. We are just using Booster 19. That's outright crazy stuff. The likes of which the spaceflight industry hasn't seen yet. Here's a post from Elon Musk on X from January 4th. He stated that SpaceX could reach an annual production volume of 10,000 ships at some point. Of course, the post was met with skepticism. Highly exaggerated, unrealistic, typical Musk stuff. Right? Right? After seeing my estimate from just Starbase and Roberts Road, what do you think? Would this be possible? Don't answer yet. With 2 gigabays, Starbase could crank out 576 ships per year. Optimize the building process further, and you can maybe even double that output. 1,152 ships. SpaceX won't nearly need as many boosters as ships. They've already demonstrated the catch and reuse process. So let's say 1,000 of those are Starships. Likely even more, but that's a nice and even number. SpaceX would need 9 more Starbase factories and 18 more gigabays, leaving Florida out completely. So, about that question again. What do you think? Are 10,000 ships per year doable? And if so, will SpaceX ever hit this number? Let me know in the comments. If you want to help us make even better content and fly more often in a helicopter, hit the subscribe button to stay informed. Like this video if it brought you value and become a wise supporter for those extra heli flights. Be our fuel, chat with me and gain more insights into the topic you love. Thank you very much. We didn't just spot the gigabay on our flight. Richard did an amazing job. Also visible at Roberts Road is the second Florida tower, likely intended for Slick 37. It's ready for stacking, just waiting for the foundation at Slick 37 to be completed. And here is Slick 37, the place where 2 Starship towers will be erected shortly. These images are from Wednesday, January 6th. SpaceX's progress here is nothing short of massive. Let's compare this to our last Cape flyover from December 5th, 2025, so 1.5 months ago. What changed since then? Quick reminder, if you want to see how SpaceX is doing at Starbase from the air, visit redlineheli.com/Felix. $25 off for anyone using the link. The Redline helicopter team will show you the same Starbase views our photographer gets on his Starbase flights. Incredible stuff. Alright, Slick 37. What changed since our last flight? What is immediately apparent is that the construction and remodeling work has now engulfed the entire site. Everything is dirt now. The grass is gone. One of the 2 large spherical commodity tanks is gone now as well. The other one will likely follow soon. The retention pond on the left side is also gone. Extensive terrain grading work is happening all over the place. While under the 1 remaining commodity tank, work seems to be focused on preparing the terrain, this process seems to be done on the right side. SpaceX released a rendering of what the pad is expected to look like when complete, but there are some obvious issues. For one, the size of the tank farm seems very small compared to what SpaceX is building at Starbase. This might be the spot where the tank farm will be situated instead. Hard to tell right now. What's also noticeable is this very large crane on site. It's missing in the December 5th shot. This is a strong signal that SpaceX is about to begin construction rather than just terrain grading. There is no doubt, Slick 37 is the larger project than Pad 39A in the long term, but the most iconic pad at KSC has one big advantage. It's further along. It's right next to where Artemis 2 will hopefully launch in not even 2 months from now, and while SLS is a last remnant of the era of non-reusable rockets, this is the mass production future SpaceX is planning. This pad should be ready for Starship launches within a few months. Visible progress was made on the commodities raceway snaking in from the tank farm on the left. It's now reached the backside of the pad. And remember the foundation I talked about last time we took a look? It's now a full-blown GSE bunker. The tank farm itself is much more finished as well. Lots of vaporizers were added. One additional large bullet tank was added. It's absolutely fascinating to see how much larger the Starship launch tower is compared to the Falcon 1 on the old launch mount. Expect launches from here toward the end of 2026. We're entering a new phase in spaceflight. From a few launches per year to thousands in just a decade. In the last episode, I highlighted Artemis 2, Blue Moon, and the IM-3 mission all set to fly in 2026. Another company that is joining in on the lunar fun is Firefly Aerospace. The guys from the Rocket Ranch have chosen to attempt another first for an American spacecraft. Blue Ghost Mission 2 is planned to land on the far side of the moon, and the mission is far from a tech demonstrator. It carries payloads from 5 countries and will deploy one of the most ambitious scientific instruments ever sent to the moon. This is the Lucy Night Radio Telescope, a collaboration between NASA, the Department of Energy, and UC Berkeley. This instrument will remain active on the otherwise powered off-lander for up to 2 years. Its purpose is to listen for faint radio signals from the cosmic dark ages. That is the era before the first stars ignited. Why was the far side of the moon chosen as the landing site? It's basically all about location. The moon's far side provides perfect radio silence, shielded from Earth's electromagnetic noise. It's an ideal place for scientific observations, and Lucy will be the first of many telescopes to follow in the not-too-distant future. The Blue Ghost 2 mission will showcase the capabilities of Firefly's Elytra Dark orbital vehicle. It'll first deploy ESA's Lunar Pathfinder communications satellite into lunar orbit before sending the Blue Ghost lander to the surface. Lunar Pathfinder establishes crucial infrastructure, being the first commercial relay satellite enabling communications for polar and far-side missions that lack direct Earth line of sight. After delivering payloads including the UAE's Rashid 2 rover and Australia's Spider seismometer, Elytra Dark will remain in lunar orbit for over 5 years. Wait, 5 rovers on a single mission? That is wild. It is getting crowded up there. And what is Elytra Dark up to, staying in orbit all this time? It'll operate Firefly's ocular imaging service at a resolution of 0.2 meters. That is detailed enough to plan future landing sites or even spot equipment left by earlier missions. We're still not done, all in 2026. Another lander is undergoing final preparations for its journey to the lunar South Pole. No earlier than July 2026, Astrobotic's Griffin lander will launch carrying one of the most commercially intriguing payloads ever. Mounted to Astrolab's Flip rover is a multispectral camera designed to hunt for helium-3, a rare isotope worth up to $20 million per kilogram here on Earth. And this is where we cycle all the way back to Apollo 17. Moonwalker and former Senator Harrison Schmitt is the executive chairman of Interloon, the company that developed this camera. Helium-3 has applications ranging from medical imaging and quantum computing to cooling systems and, at least theoretically, potential fusion energy. Griffin also carries Astrobotic's own shoebox-sized cube rover. Yeah, that is 2 more moon rovers for 2026. Let's rock and roll. The Flip rover, weighing approximately 500 kilograms, tests technologies for lunar mobility, including specially designed airless tires designed to withstand the moon's harsh environment. Flip is the predecessor of Flex, Astrolab's full-size rover under development. This rover can carry both cargo and astronauts and is competing to join NASA's Artemis program. Even though not all of them will deliver cargo to the moon, rocket madness is rampant in 2026, and we will see many exciting firsts. Los Angeles-based Relativity Space targets late 2026 for something equally revolutionary: Terran R. Relativity Space's new rocket blends additive manufacturing with traditional aerospace techniques to create what may become one more serious SpaceX competitor. The specifications are impressive. At 86 meters tall, Terran R towers over most rockets in its class. It's a big one. 13 A&R engines enable a payload capacity of 23,500 kilograms to low Earth orbit when reusable. This exceeds even Falcon 9's capability and outperforms Neutron by 10.5 tons. Okay, that is impressive. But what makes this rocket so special is its unique manufacturing process. Relativity's secret weapon is Stargate, the world's largest metal 3D printer. Its latest iteration prints 7 times faster than its predecessor. It is now possible to print 4 complete rockets per Stargate unit annually. 3D printing is also a key enabler of new possibilities in engine manufacturing. Relativity's engine design can now include internal cooling channels that would be impossible to manufacture conventionally. Same as SpaceX's Raptor 3. The approach paid off in October 2025 when a flight-ready A&R engine completed a 475-second static fire, simulating the full duration of an actual launch. Yes! At Cape Canaveral's Launch Complex 16, construction crews have installed the first propellant tanks and begun excavating the flame trench that will channel exhaust away during liftoff. I'll keep a close eye on this launcher, which is set to become an end-of-year treat. In Europe, 2 companies also aim to bring their new orbital launch vehicles to the pad for the first time. In sunny Spain, PLD Space is out to make Spain part of an elite club, countries with independent orbital launch capability. PLD Space earned credibility on October 7, 2023, when its Miura 1 rocket became the first privately developed European rocket to reach space. That suborbital flight validated approximately 70% of the technology destined for the orbital version, including the TEPREL engine family. They'll provide the power needed to launch more than 1,100 kilograms to low Earth orbit. Miura 5's TEPREL C engine represents Europe's most powerful privately developed rocket propulsion, each producing over 19 tons of thrust, more than double the nearest European competitor. 5 of these engines cluster on the first stage, burning RP1 biokerosene and liquid oxygen. And Miura 5 is almost ready. PLD finished building its first fully integrated qualification model in November 2025. Now it is time to finish the pad. Construction continues at the Guiana Space Center in French Guiana, where PLD Space will become the first private company to operate from the historic ELM Diamant launch site. At this point, the project is on track for a launch later this year. So we'll continue this one more time on the next episode. Man, this is nuts. Welcome back to the Why Countdown, your rapid-fire look behind the curtain at everything that keeps this channel blasting off. And today, I'm actually not talking about why or me. I want to share a very important reminder with you. Tim Dodd is almost ready to present this year's greatly improved Astro Awards. And I want 2027 to have an Astro Award presentation as well. I think it's very important work. One thing is absolutely guaranteed: excitement. He has a crazy lineup of guests, and the one thing missing right now is ticket sales. If you love what Tim is doing there and want an epic Saturday and Sunday next week, consider buying a ticket. He needs 200 more tickets sold ASAP. Spread the news, fly in your grandma, I don't care. She'll love it anyway. Go to astroowards.life for more information. Thank you so much for considering it. I wish I could be there myself. Thanks for being our rocket fuel. We're all in this mission together. And that's it for today. Smash the like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. Our brand new Raptor emblem design and countless others are there for you to explore. Click the card or the US or worldwide link in the description. And if you want to know how SpaceX managed to build Raptor 3, the new Starship powerhouse, and what makes it special, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode.